Hey, here we are, Pave the Trail, day 88. Make sure you have your name so you get credit for this, and let's get going. Remember that last lesson, we combined everything we'd learned about area of any type of shapes, and we used all that knowledge to find the area of composite figures. So I can see two shapes here. I see a square, which is going to be base times height. And the base and the height are 3, so it's a square. So we got 9 centimeters squared here. And then this shape right here is not a triangle, is it? But I do see a parallel line here and a parallel line here. But it's not a parallelogram because those are not parallel, which means it's a trapezoid. So that's when we go base plus base times by height and then half it. I'm going to remember that with my bases, the bases are the two sides that are parallel. So it's not these two. Those are not the bases. It is this and this. So I have a 5. Oh, that's weird. I have a 5, but then what is this base right here? Well, it's connected to the square. Remember, the square had a side of 3. So that's going to be the same side as that base right there. And the height is 5. So we got half of 8 times 5. Half of 8 is 4 times 5 is 20 centimeters squared. Then I'm going to add them up. 9 plus 20 is 29 centimeters squared. I'm interested to know if I make any mistakes. Got a rough couple days there. I think I'm back on track. We're going to go for no mistakes. All right, find the area of this regular polygon. I'm going to start with a triangle. And the triangle base is 19. The height is 16.5. Definitely going to use my calculator for that. 0.5 times 19 times 16.5 gives me 156.75. But that's just for this triangle right there, isn't it? I can see that there are actually a total of, let's see, 6 of those. So now I'm going to times that by 6 and get 940.5 centimeters squared. Whew, feeling good so far. Find the area. Shocker. It's another find the area question that we've had these last few lessons, isn't it? Now we've got a triangle. Again, it's base times height, and then we half it. So all I need is the base and the height. There's my little perpendicular 90-degree. So that means I will need this line for the height, that line for the base. The 11 can just go away. We don't need 11 if we're just finding the area. So that's going to give me half of 12 is 6. 6 times 8 is 48. Ooh. It doesn't say if those are 12 inches or 12 feet or 12 miles, does it? So this is when we go units squared. 4 lessons ago, it's another trapezoid. But we're not finding the height area, we're finding the height. So I'm still going to use the trapezoid formula, but I'm going to use that information. So I've got the area, so I can start off with a 255 equals 1/2. I do know my two bases is 12 and 22. What I don't know is the height. So the height, the H is going to stay in H. I'm going to take, do parentheses first. 12 plus 22 is, let's see, 34. So now I have half of 34. I have a lot of kids that think that 34 is the answer. It's not. Or I'll have kids get 17 right here and say that 17 is the answer. It's not. We've got to figure out what H is. H is our height. So what we're going to do is I'm going to write it over here. And we are going to solve for H. I want to know what the height is. Whoa. So I'm going to divide that by 17. Divide that by 17. And that will give me 255 divided by 17. And that gives me 15. And it's just inches because it is just that length between those 2 points right there. Okay. The biggest mistake I see with these, and maybe you did it too, is that you don't take half and you end up going 255 divided by 34, and you get an answer that is only half what it should be. So make sure that you take and find the half of trapezoids and triangles. Okay, what is the area? What does this look like? Again, it looks like a trapezoid. Whew! We are really making sure that that trapezoid formula gets stuck in our brain and that we will remember that forever and for always, making 7th grade so much easier. So I did the 1/2 base plus base. I have a 25 plus a 32, and that gives me 57. Now I need to take half of that, and so times it by 17. I'm going to plug that whole thing in my calculator. So clear 0.5 times 57 times 17, 484.5 inches. This one was area, so that's why I included the squared right there. All right. Whew, finally get to go to a different chapter. This was from chapter 9. What is the equation? So we know that equations are always y equals x, right? And what we're figuring out is, what did we do to the x, or what did we do to all of these that made it so we got the y? So what could happen to 4 to get to 0? Well, it was either 4 times 0 or it was 4 minus 4, right? Those are the two options. But if I look at this 5, what could have happened with the 5? Well, 5 minus 4 is 1. 5 times 0 is 0. And if y ended up being 1, that means it must be this. And that works here too, huh? 6 minus 4 is 2. 7 minus 4 is 3. So the rule is whatever the x is, we're going to minus 4, and that will give us the y. So that is the equation for that xy chart. Ooh, this one we've got to write and solve an equation. So because it says equation, it needs to have an equal sign in it. Lily had some money. She earned $25 more, and now she has $90. How much money did she have before? Okay, so Lily had some money. It doesn't say how much money she had. So this is where I have to use a variable, like X, right? X stands for the money she had. Then she earned 25 more. Both earned and more lets me know that she added $25 to what she already had. And now, so that equals, now it is $90. So we just wrote the equation. Now we got to solve it. So I need to find out, well, how much money did she have before? So at first I'm going to isolate the variable. So that'll give me 0, and I'll have x by itself. And then because there's an equal sign, to keep things equal, I needed to do the exact same thing on the other side. That gives me 55. So x is 55. She had $55 before. Let's see if this makes sense. If she had $55 before, then she earned 25 more. Does that equal 90? Well, let's check it out. 55 plus 25 equals 80. Where's my mistake? See, I see it. See, that wasn't making sense. I was like, that's not enough. It was right here. Did you guys catch my mistake? It doesn't count because I caught it before you. Okay, so that should be an 8. So then that should be the 6. So she actually had $65 before. Dang, am I glad that So here's what I did, is I took this x equals 65. I put it into this x, and I did 65 plus 25. and it didn't equal 90. So I knew it wasn't 55. But when I put the 65 there, it was. So I'm glad I double checked my work. 20 lessons ago, write an equation for the word sentence 18 more than a number is 29. Okay, it's another equation, so we're going to go equal to. 8 more than a number. 8 more than a number is 29. Now you might be like, Miss Matson, you tossed more than is a turnaround word. You're right, so it could go like this. But because it's addition, order doesn't matter. So either way would work. Put the numbers in order from least to greatest. Least is the biggest negative, and then getting closer to 0. And then the greatest is the furthest from 0 on the right side. So those are the numbers from least to greatest. 60 lessons ago, we were finding percentages. It is a percent problem, so we could go 15 over 100. And then we want to find that part of 80, so we're going to leave it like that. Okay, so because we're looking for the part right here, we already have the whole. I could do this the decimal way. I could change 15% to a decimal, and I could solve that and get 12. Okay. Or I can continue to do it the decimal way or the ratio way and be like, all right, let's see what happens if I simplify this. That'll give me 5, nope, that'll give me 3 to 20 equals 80. And then I can be like, oh, it's a times by 4 relationship, and that'll give me 12. So no matter which way I did it, I got the answer is 12. And then 80 lessons ago, we were comparing decimals. To remember that just because this number is the longest doesn't technically mean it is the biggest. What we need to do is we need to line these up and then compare. So those are the same. Those are the same. 8/10, 8/10. Ooh, here is the difference right here. We've got 700ths versus 600ths. 700ths is bigger than 600ths. Okay, the other thing we could do is we could put a 0. We could say, well, 70 is bigger than 62. So either way you look at that, the 43 and 8700ths is bigger.